I'm going to be talking about lime sources and then some basics, some things to keep in mind if you are making a lime application. And so there's all sorts of lime sources. Agricultural lime is kind of the standard. That's predominantly calcitic limestone. There is dolomite limestone, which has some magnesium with it, but that is more so where everything is based off of on this scale. So there's this calcium carbonate equivalence range. So that's what that CCE is over in the top right corner of this slide. And so if you have 100% limestone, that's considered 100%, as the carbonates are what react with the hydrogen, and it produces some CO2 as well as water during that chemical reaction. Now there's other things out there, such as the quicklime, which is about halfway down, and on the right side has a CCE range of 150 to 180. And that's more effective at neutralizing, I shouldn't say more effective, but you can use less product to have the same impact as you would with limestone, because the oxygen is reacting with the hydrogen, so it's producing hydroxyl, that's OH minus, or it could produce water as well. Then there's other byproducts that we're starting to look into. There's fly ash, which that's a byproduct of the coal mining industry, and we have a lot of that in North Dakota. We're starting to do some work on that, but some work that I found showed that it had about 42% for calcium carbonate equivalents. Water treatment lime, all of our local municipalities use lime for their water purification process. And some information I found was somewhere around 72 to 87% on that. Beet lime is where Ryan and I have been doing the majority of our work. We've been getting that from Sydney, Montana, and that usually ranges somewhere around 66%. Now I have gypsum listed here just because we get a lot of questions about liming amendments, and gypsum does not neutralize acidity because it's not the calcium that neutralizes the hydrogen, it's the calcium carbonate, that CO3 that does the neutralizing. The sulfate, if that mixes with hydrogen, that's going to just produce sulfuric acid in the soil. And so that doesn't have any sort of liming equivalence. Now, maybe some sulfate added to the soil could tie up some aluminum, but for the most part, I would look in some sort of liming amendment. And so, like I said, we've been using beet lime for our research, and it's important to test it. Out of 6 or so beet lime tests that we've done over the past few years, all the way on the right-hand side, we have the calcium carbonate equivalents. There's anywhere from 1,100 to 1,500 pounds of lime per ton. And so that's a huge variance. And when we're talking about $50 to $100 or maybe even more per acre, it's important to test this on a regular basis. There is also some nutrients with that. Usually there's somewhere around 5 pounds of nitrogen, 12 pounds of phosphorus, a smidge of potassium, and then some other micronutrients. There's some trace amounts. We haven't seen fertilizer responses yet, but some work over at Crookston at the research center there from the University of Minnesota has seen increased levels of soil testing phosphorus after lime application. So maybe there's some fertilizer value with using this beet lime, but we haven't quite figured that out yet. And so not only does the source material matter, but the size, that particle size, matters greatly. The bigger the particle, the less surface area there is. Smaller particles have greater surface area, and they're much more capable of reacting with the hydrogen within the soil. And so when you have a liming material, particle size is important, and so they'll do some screening on that. And if all the particles are less than or will pass through a 50 mesh size screen, that's 0.3 millimeters, which is about the size of a silk grain, we consider that all of that product would react with the soil. However, a 10 mesh screen, so it's a much coarser screen, that's about 2 millimeters in diameter or larger. So now we're talking about gravels. And so hardly any of that would react with the soil. And so you should know what your particle size is. And there's this equation here, the effective calcium carbonate equivalence, that accounts for limestone, so that's the percent CCE. And then also it accounts for what passes through that 10 mesh or what passes through that 50 mesh to really tell you how reactive and pure that lime is. And so I'm going to talk a little bit about application methods. These are some hand-applied trials that we did up at Minot. In the foreground is 2 tons, in the middle is 8 tons, and in the background is 4 tons per acre. And so there's all sorts of different spreaders out there. Lime spreaders are designed specifically for lime just because they have a much wider belt to apply that lime, because we're looking at applying tons of product per acre. A standard fertilizer spreader is designed to only put a couple 100 pounds down. So you may be able to use that, but it's not the most effective tool. So what we've been doing is using manure spreaders. And so this is a horizontal beater that we used up at Minot a couple years ago. And the horizontal beater we found doesn't do a good job of a uniform application. You can see how there's clumps here, then there's no area where the lime was applied. So the distribution with the horizontal manure spreader is very poor. But we found that a vertical beater does a pretty good job at being uniform with applying the beat lime. And so this is what the distribution pattern looked like when we were doing some calibration back in December. And so regardless of your application method, you need to calibrate your spreader properly. And so what we've been doing with our calibration, we've been doing the sheet method. There's the Nutrient Management 1418 publication that NDSU has that talks about this. But essentially, you put a sheet out, you know what that square footage is of the sheet. You drive over the sheet, be sure to anchor it down because it can blow away on you. And then you weigh it in a scale. So you have the initial weight with no lime. You can figure out how many pounds of lime is on that sheet, the square area. And from there, you can calculate what your application rate is. And so lime is costly. You need to be site specific. We've had lime custom hauled to Minot and applied, and that came out to about $50 per ton. This all came from Sydney. And we did the same thing over in the Leffer region last December. And again, that came out to about $50 a ton hauled and applied. And the big reason why we're seeing, one of the big reasons why we're seeing the soil acidity issue in Southwest North Dakota is because of our clay types. So this was a map developed by Franzen in 2018, and the dark grays and the blacks are areas that have a lot of kaolinite clay. And so those areas have one-to-one clays that don't buffer as well as schmectites that you would see as you would see east of the Missouri River. Those are 2-to-1 clays. And so the buffering ability isn't as great in our region, so we don't have as much of resistance to a change in pH. And even back in the late 90s, we were seeing some acidic soil conditions. So Dr. Franzen went across the state and evaluated 3 sites in every county and developed this map. The top map is showing side slopes, and the bottom map is showing depressional areas for this project. The red is the acidic areas, the green is the alkaline areas. And you can see even back then, some of the side slopes did have some acidity issues. But when we get into the depressional areas, the amount of acidity greatly increased. And so here's what we think is going on with these areas. These depressional areas, as well as the summits, have more topsoil because the water can infiltrate into that soil. It doesn't run off like it would on a side slope. And so the carbonates tend to be deeper on our topsoils and our depressional areas, or our top slopes in our depressional areas. But the other thing that happens is the clay that does a lot of this buffering, they can weather down in those summits and those depressional areas versus the side slopes. The clays are usually close to the surface, but also that those carbonates that can naturally fight off the acidity are near surface on those side slopes. And so fixing these areas, like John showed earlier, zone sampling, we need some precision agriculture to figure out where these areas are. But when you get that composite soil sample, it may come back as a pH of 6.5, which is great. But if we start looking at it in zones, there could be some soil acidity issues out there. And again, sample that 0 to 3 and 3 to 6 inch for the pH. But you still want to do that 0 to 6 inch soil core for your nutrient analysis, just because that's what our phosphorus potassium recommendations are based off of. You can also do some digging around in the soil, and if you see some carbonates near the surface, you probably don't have an acidity issue. So in summary, you got to test your lime source if it's a byproduct. The agricultural grade lime out there that's running 95, 98%, that's great stuff too. Be site specific with your pH management, and also calibrate your spreader. And so that's all I have, Ryan. Thank you.